This is Geometry, Unit 8 of the Semester 2 Final Exam Review. We're looking at the first group of questions for trigonometry. I look here and we're solving for a missing side of a right triangle. So we're going to use Pythagorean theorem. Pythagorean theorem is used to solve for one side of a right triangle. So I like to write it as hypotenuse squared equals leg squared plus leg squared. We have the hypotenuse. Very important that the hypotenuse get placed in the hypotenuse spot, and the two legs gets placed in the leg spot. So we'll come over here and say that 15 squared is 225, and we subtract the 81, or 9 times 9, get 144. Now I have x squared. Well, I need to take the square root, so x is going to be 12. Take the square root of 144, and that gives us 12. Here we have the same story again. We have a right triangle. We know two sides. We're looking for the third side. Pythagorean theorem tells us to do x squared equals 3 squared plus 6 squared. Now notice that the hypotenuse is the variable this time, so it is on the outside. It's common to mistakenly put the x on the wrong side over here, but here it's appropriate, so you just got to pay attention to put the right side in the right spot. So this adds to 45, and we take the square root of both sides. So when you take the square root of something squared, you're going to get x, and 9 times 5 is 45. So we know the square root of 9. So that's 3 root 5. Here we're going to look for the area. Well, the area formula is half of base times height. This is your base. This is your height. It really doesn't matter which is which. But we have to calculate for this value. So Pythagorean theorem won't work. 31 is not a side length. It's an angle. So we have to use trigonometry. So this would be considered the opposite. This would be the adjacent. So that's using SOHCAHTOA. That's going to be tangent of 31 equals the opposite over the adjacent. We can place a 1 underneath there if we like and cross multiply. That's going to tell us x times the tangent of 31 equals 17. Now we're going to divide by the tangent of 31. Divided by the tangent of 31. You need to be sure you're in degree mode. You know that by hitting the mode button and seeing degree. Very important. Second quit takes you back to the screen. We get 28, 29. So that is this length, 28, 29. And then to find the area, don't forget what we're doing. The area is half the base, 28, 29, times the height, which is 17. So we've got 28, 29. You could use the previous number, that would be outstanding to do. Times 17, and we have to divide that by 2, or times it by 0.5, or times it by 1 divided by 2. Anyway, we get an area of 240.4 rounded up to 7, and these would be just units squared, square units. Find the area of a right triangle with a hypotenuse of 15 and a leg of 12. So we need to figure out what the height is. Here we can use Pythagorean theorem. So the hypotenuse goes in the hypotenuse slot, the leg goes in the leg slot, and the other leg goes in the other leg spot. 225 equals 144. I feel like we've used these numbers already today. So this leaves us with 81. So x is going to be the square root of 81, which is 9. So this guy is going to be 9. But that's not the question. The question is, what is the area? Half of base times height. Half of 12 times 9. So you can take half of 12 if you want. And that's 54. That's centimeters squared. You don't take half of 12 and half of 9. You take half of either one of them. Find the perimeter and find the area. But again, I only have 2 sides. I need a third side. So we know 2 sides. We're told that this is a right triangle, so we can use Pythagorean theorem. So 137 squared equals 88 squared, and our unknown. So 137 squared and 88 squared So I'm going to take that number and subtract that number, subtract it across. And I'm going to take the square root of that number. And 105 is what x is. But that's not the question. The question is, what's the perimeter? Well, the perimeter is all three sides added up. 88 plus 137 plus 105. 88, 137, and 105. So we have a perimeter of 330 inches. That's a straight line, so it's just inches. Then we have an area. This is a triangle, so it's half a base times height. So our base and height have to be perpendicular to each other. It doesn't matter which is which. So if we want to say 105 times 88, we can do it that way. Or you could take half of the 88 and times that to 105. I haven't used the half yet. I've times the two together. Now I'm going to take half of it, divided by 2, or times a half. So So that equals 4620 inches squared. So decide whether the numbers can be represent the sides of a triangle. Alright, so to represent the sides of a triangle, we have to know if they're going to add up to equal the whole thing, more or less. So here's an example. I have 3 lengths. If I want to see if these 3 lengths can make a triangle, I can't touch them together. These lengths don't make a triangle. So what do we know? We know that the 2 small sides have to add up to be more than the longest side. If the longest side is too long, it can't make a triangle. But if the longer side is a bit shorter, so the 2 short sides add up to be greater than the longest, you can make a triangle. So that's what we've got here. We've got to check that out. So I'm going to check with the 2 smaller sides, so 62, and I'm going to compare that with the 26 and the 35. So 62 and 61. So 62 is larger. The longer side is too big. Not a triangle. But over here, the 2 smaller sides, we've got the longer side. Usually we don't love turning things into decimals, but just to do some comparisons, we've got like 12.7, and we're going to compare that with 5 plus 8. So 12.7 is less than 13. Not by much, but it's less. So yes, it makes a triangle. So next we're going to figure out what type of triangle it is. So we take our largest side and we square it. We're going to compare that with the other 2 sides squared. So you square your 9, square your radical, compare that with square the 5, square the 8. So this becomes 192, this becomes 89, so this is clearly larger. Now, if the larger side you put first, then this is going to be obtuse triangle. If it's larger, and we always want to set it up like hypotenuse, leg, leg, we always want to put the longer side first, then this is going to be an obtuse triangle. Remember, it barely fit, so it had to be really wide for it to have reached. So it's got to be obtuse. On this one, we know that the largest side is 34, and we compare that with 16 plus 30. So 34 is less than 46. So yes, a triangle. That doesn't mean acute. It just means it's a triangle. That the 2 smaller sides have to add up to be bigger than your larger side. Now we're going to do essentially Pythagorean theorem. We're going to square that, square this, square the other. We can't really call them legs or hypotenuse. It's not a hypotenuse unless it's a right triangle. But we don't know if it's a right triangle. But we're going to test it like it is. 1156, and we're going to compare that. 30 squared is 900. 16 squared is 256. Hey. And when we add that together, we get it to equal 1156. So those are the same. So we have a right triangle. Alright, just a couple more. We're just going to do 9 through 12 here. We're working with special right triangles. In a 45, 45, 90 triangle, we have the hypotenuse is going to equal the leg times root 2. So I'm going to put the hypotenuse equals the leg times root 2. So I'm going to get the x by itself by dividing. Those are going to cross out, and 5 equals x. This is a 30, 60, 90 triangle. So a 30, 60, 90 triangle has two rules. The hypotenuse equals the short leg times 2. And you also have the long leg equals the short leg times root 3. So we know what the short leg is. So the hypotenuse, well, that's x, equals the short leg, 4 root 3, times 2. So this is going to be x equals 8 root 3. And then we're going to figure out this other leg. The long leg, which is y, equals the short leg, 4 root 3, times root 3. Well, that's going to be y equals 4. Root 3 times root 3 is 3. That gives us 12. So I'm betting that 8 root 3 is actually bigger than 12. It has to be for this to be a right triangle. It's bigger than 12. The largest side across from the 60 is the next largest side, and across from the 30 is the next largest side, the smallest. All right, this side is a 45, 45, 90. So the hypotenuse equals the leg. We don't have to call it short or long. They're the same. Times root 2. So we have 7 root 2 equals x root 2. And we divide by root 2. And x equals 7. So y is going to be 7. If the legs are the same length, then those x and y are going to be the same. 30, 90, so this has to be 60. So I know the short leg times root 3. Long leg equals short leg times root 3. The long leg is 6 root 3, and the short leg is x. So divide by root 3, divide by root 3, and x equals 6. That's not a surprise because the short leg times root 3, 6 root 3, is the long leg. So by going backwards, you're taking away the root 3. So the hypotenuse is going to be 6 times 2, which is 12. And there we did it. Hypotenuse equals short leg times 2. Kind of ran out of room. The next group of questions will be on the next video. Good luck, everybody.